My name is Jessica Siewert, and I'm a Scala developer at Simacan. Um, at Simacan, we provide our customers, like grocery stores, with real-time control over their transportation of goods. They can supply us their transport planning, and we combine that with GPS and traffic information and give them the ability to adjust on the fly. We have a stack of microservices, and we provide 24/7 support on them. We can do that because we continuously invest in the robustness of our services. And ideally, we want to be always available, complete, and correct. This is very important to our customers as their transportation is happening live and now. And therefore, it's also, of course, very important to us. So, what I want to share with you in this session is 10 things that we have learned in the past time to achieve more robustness. So let's get to our first lesson learned right away. We like to handle the responses of other microservices that are more internally, like they are the responsibility of the microservice facing externally. What happened here was that a customer supplied us their planning, but didn't see quite all of it at the other end. So we went looking, and it turned out that some internal service had decently logged that I'm missing this and this data, so I cannot do my job. We told it to the customer, they added the data, sent it to us, and everybody was happy. Well, except for that, we'd like this to happen automatically. So that's why we say this, that every service is responsible for what's happening behind it. So that immediately gets me to our second lesson learned. As when we did this, we started getting calls from customers that they didn't really understand what the messages were saying, like a field not found exception or something like that. So we had to spend time, of course, to explain them what it meant. So it wasn't really working for us yet. So at some point, we told one of our delivery managers, you know what? These are all the validation cases we foresee with the data that can be not quite right. And go see the customer and ask them, in each case, what would you like us to tell you? So we built that in. And since then, things happen, but the customer is really capable of independently improving their data set and adding the data that's needed. So it saves everyone a lot of time. But then still, sometimes a customer has a question about something that's happened right now or in the past few days. And they work with names for things, of course. The name of the person who drove the truck, the name of the store, the name of the goods, maybe. And we are using unique identifiers, UUIDs and stuff. So if we go look in our logging, then we really can't relate to how they call things. So that's why we started to put relevant identifiers for our customers into our logging. Whenever something goes wrong, we log. We don't log when everything goes right. That would make our log exponentially explode. When we want to know how our services are doing, we use metrics. And metrics are really cool. And when I started working at Simacan, I saw these big screens with all the graphics and how much data was flowing through a system. And I was thinking, yeah, we build metrics and we know how our servers are doing at any time. So you really wouldn't think that you can have too much metrics, right? Well, you can. At some point, we got a call from Datadog, the platform we're using, and they said, guys, if you don't get it down, we have to give you a very, very, very scary high bill. So we looked into it, and it turned out actually that there are 3 things that got our metrics really exploding. The first one is metrics we built, but after a while we stopped using, but they kept remaining in the system. The second is the automatically generated helper metrics, like medians and averages and sums, that automatically are generated by the platform and also by the library Camon that we use between it. So this can actually multiply the amount of metrics you use with a factor 5 or a factor 10. Then the third thing was that we used lots of tags. And tags are kind of like labels you can put on a metric to categorize the metrics by customer or by town or whatever. But every unique combination of values of 2 tags is considered a new metric. So this exponentially exploded the amount of metrics, up to over 30,000 we had. So we got this right down, and everybody's happy. And we still got these screens, but actually what's on it, when it changes, it really matters that it changes. Otherwise, it doesn't need to be on it. So one of the cool things about metrics is that you can also put alarms on it. And this is really helpful, for instance, when a service starts restarting itself all the time. You can notice, you can fix it, but let's not get past this environment that does this too fast, because when you have a set of microservices that is open to the outside world and continuously processing data, you want to be in an environment that if something's up with the service, it goes out of memory, automatically restart itself, continues with processing the data exactly where it left off, and notify you in the meantime, so you can investigate what's up, fix it, while the customers aren't noticing at all. And that's really, really cool. We're using AWS, by the way, and some other stuff, but if you want to know about that, come find me after the talk. So one thing that happened once to get one of our services out of memory was basically because we weren't explicit enough about which service was responsible for the quality of the data. So we had a service processing lots of data and handing off specific pieces of it to internal services. For instance, we had a coordinate for a location where a truck should go, and it was handed off to a service that would geocode and actually put that on a map. The service processing the data, it checked that it was a number, but it was completely agnostic, as we like with loose coupling, about that it was a coordinate or what it was going to be used for. So it handed off the number, and the microservices doing the coding was trying to put this on the map, but the number was so big that this would only have worked if the world would have been 10 times larger. So we found that out and fixed that. And since then, we really tried to be more explicit about should this service have validated that before you started calculating, or should the processing service do? It doesn't really matter as long as you make a choice. So when we got all that sorted out, got the logging decent, the metrics, we can restart, we can validate wherever we want, it's so clear. We make a new service. And as we are an IT company and at heart, and our customers, they do have IT departments, but usually we're faster at building and delivering something than they are, understandably. So what we used to do was, we're going to make this new API, and here we have an endpoint, and it should take this data because that's very handy for that service. And customer, we build it, and here's the API. Then we would hear nothing for about a few weeks, and then the customer would say, well, that's not very handy for us. Can you change that a little? And of course, we like to accommodate. And in the end, we found out that by the time we were up and live, we had rebuilt half, if not whole, the thing. So we thought, okay, we can do that smarter. We can do that earlier. So we started doing that earlier. And at the end of the road, we start with designing the API. So we think of the API. We don't build anything yet. We give it to the customer, deliberate with them, and when we are about 90-95% on an agreement, we start building. So then when we put it all live, and we're very excited, and our customer's very excited, and we try to test as much as we can beforehand, but nothing is as real as the real thing. That's also true for data that you get from the outside world. So what we do is, it's a bit expectation management. We put it live, the customer can use it, and with that we say, you know what, in the next 2 weeks, we put a buffer in our sprint, if they know what that is, and if something's up, we're right there for you. And the customers are very happy because you respond so adequately. For us, it's very handy because we don't have to say like, oh shit, something's up. We put that live last week, right? Oh shit. Maybe we can fix it 3 sprints from now. That's not where you want to be. So we call it an integration test period or whatever you like. So while you're on it, make sure you do 2 things. And these are my last 2 lessons learned. So while you're on it, agree with your customer what you're going to do with partially correct data. So it can be that they send in an event and some fields are correct and some are not. Or on a little higher level, they send in a transport planning, but they never tell us who is going to drive that truck or what truck is going to drive it at all. So these things are really handy to discuss and not to wait until it actually happens and the customer is on the phone because I want to monitor my truck now. So do that in the integration test period. And last but not least, also discuss what to do with outlier values. Albert Heijn, one of our customers, they can very well open a shop on an oil rig in the middle of the North Sea. But probably if I get a transport planning with a stop in it, a shop in it, in the middle of the North Sea, let's say I'll get that planning next week, that's probably not their intention to put that shop in the middle of the North Sea. But the services don't know. And as the amount of data flowing through gets larger and more, you probably won't see it. So try to discuss this with your customer up front. What's going to happen and what are we going to build in to prevent these things? Maybe a geofence or I don't know. It's all about that you're on it. So these were my 10 learnings for more robustness. Thanks to my colleague for drawing the icons. Well, if you want to rate my talk or have any questions, I'd like to hear from it. So thank you very much and have a good day.